Hello everyone. So in this presentation, we are going to discuss about one of the symmetry elements, the proper axis of symmetry. Proper axis of symmetry, otherwise can be called as n-fold axis of symmetry or the symmetry axis of symmetry of order n. So the definition comes over here as if the compound is rotated through a certain axis, through a certain angle theta, then we get indistinguishable compound, then it is said to be the axis of symmetry. And it is denoted by the symbol Cn. C stands for cyclic, N represents the number of fold axis or order of the symmetry axis. Then theta here, that is the angle through which the object is rotated in order to give an equivalent configuration. Here we could take a simple molecule H2O as an example to illustrate this axis of symmetry. We should be knowing about the geometry as well the shape of the molecules. So the water molecule has a tetrahedral geometry and it has a bent planar shape. So first possibility is that, or one of the possibility is that, let us take an axis and we pass the axis which is perpendicular to the molecular plane. This is the molecular plane. So here the axis is just passing through the plane and it comes the other way. So it is passing through oxygen atom and it is actually bisecting the HOH angle. And we should see through what angle, if it is rotated, we'll be getting an indistinguishable configuration. That is, the positions of the hydrogen atom should be shifted. So here it is 180 degrees. So the rotation is done through 180 degree. Then we get we could see the interchange of the hydrogen atoms. So which is indistinguishable configuration, but not exactly the same as that of the original one. Then we have to see one more possibility of the rotation, whether it is possible. So you can take an axis, keep just on the plane through the oxygen atom. Again, it is bisecting the HOH. The first case, it was just piercing the plane and it is the other side is going at the bottom of the plane. But here we are just keeping on the plane. Then here again, we go for a rotation through 180 degree. It's just a flipping. So the positions of the hydrogen atom gets shifted. Then it leads to an indistinguishable configuration, which is not an original configuration, but it is equivalent configuration. Then 180 degree rotation was made. Then how to calculate n? N is equal to 360 degree divided by 180. Then we get n equal to 2. So it is a two-fold axis of rotation, which is actually water molecule is possessing. So two types of rotational axes are there. One, it is perpendicular to the plane of the molecule. The other one, it is which is actually lies in the plane of the molecule. So a proper axis of symmetry elements in H2O, that is C2 dash and C2 double dash. Then one more you can actually observe. The rotation can be done again from this one more time. It is rotated through 180 degree rotation, and you could observe that there is no 180 degree rotation. So we'll be getting again a C2 symmetry, axis of symmetry. Then oxygen atom, it lies as such. The axis is passing through oxygen, so it doesn't change. Only the positions of the hydrogen atom changes as the rotation is done here. So after this, the second hydrogen goes here and the third hydrogen comes to this position. Now, what is your observation? The configuration of this one or the orientation of this molecule is exactly same as that of the original one. They are actually same as that of the original one. So the second time whatever was carried out, it can be represented as C2, and since it is giving the original orientation, then that could be represented as a symmetry element, that is the identity element. Similar way here also, if the axis is lying in the plane like this, it is lying in the plane, then it is rotated through 180 degree. Through 180 degree, if we are rotating, then the similar observation as that of the original one will be getting. So here comes the second hydrogen, and here comes the third hydrogen. And the observation here, it is what? You will be getting a similar configuration as that of the initial one. So here both are same. So what is that? C2, it is done. This is one time it has been done. This is the second time, so it should be represented as C2. And since it is giving the original configuration, that is, it should be represented by an identity element E. Okay. So in this case, the axis was passing perpendicular through oxygen atom. That is, it is passing through the plane like this, and here it is passing on the plane. Okay, so this is what it is represented here, perpendicular plane, and here it is on the plane. So H2O molecule possesses two different C2 axes, that is, two C2s are there, in which one is C2 dash and the other one is C2 double dash. Next example is boron trifluoride, and the geometry as well as the shape, it is the trigonal planar in shape. So this is the one trigonal which is planar. So you could see the axis, one possibility is we are passing the axis perpendicular to the boron, which is passing through boron atom, and it is coming down the plane. And we have to see what is the angle between these two fluorine atoms. So since it is a trigonal planar, the angle between these two fluorine atoms, we know very well, it is 120 degree. So we have to make a rotation so that we get an indistinguishable configuration. So through 120 degree, the rotation is made. So the positions of fluorine atom has been shifted, you could see here. So the blue color fluorine atom is shifted in place of yellow, and yellow is shifted in place of red, and red is shifted in place of blue. So in likewise, we get the indistinguishable configuration again by doing one more rotation through 120 degree, and again one more rotation through 120 degree. So the first time if it is done, then it should be represented as C31. How do you get this three-fold axis of symmetry? How do you get? So 360 degree divided by the angle through which the rotation has been made in order to get an indistinguishable configuration. So in this case, it is 120. So n is equal to 360 divided by 120. Then it is a three-fold axis. So only it is represented as 3. One time it is carried out C31. The second time C32. Third time C33. But it is giving rise to the equivalent configuration, that is exactly same as that of the original configuration as that of the initial one. So C33 is equivalent to identity operation. So in BF3, we have three C2s, two C3s you have, in which one it is identity. So we should be saying two C3s we have, that is distinct C31 and C32, and one more symmetry operation, that is symmetry element, it is identity. That is through rotation through 360 degree, then we get this identity element. Another possibility we need to check in BF3, that is the axis which is passing through one of the fluorine as well as the boron. So you have to see, since it's a planar molecule, The axis is just passing in the plane of the molecule, passing through fluorine and the boron. Now we need to do a rotation in such a way that we should get an indistinguishable configuration as that of this one. So the position of this fluorine and the fluorine here in the red color has to be interchanged. So what is the angle then? Through what angle it has to be rotated here? This is the one. It has to be rotated through 180-degree rotation. So 180-degree rotation, then n will be equivalent to what? 360 divided by 180, then that will be equivalent to what? 2. So it will be a two-fold axis of symmetry. We get a two-fold axis of symmetry. Okay. So likewise, we have got 3 fluorine atoms. So 3 axes will be passing through 3 different fluorine atoms. So overall, we'll be getting C2 dash, C2 double dash, and C2 triple dash. Otherwise, we could say that 3 C2s are possible. That is 3 two-fold axis of symmetry are possible in BF3. So rotation, if it is done through certain angle, so 360-degree by n, successfully m times, if it is done, then it has to be represented by this one, CNM. That is C2 one time. If I take C3, it will be better. So C3 one time, then C3 second time, then C3 3. So C3 3, this is equivalent to what? E, identity element. So the rotation is made n times, then it should be n times of 360 divided by n. So this is the one we get. Okay, then that is equivalent to what? E. That is, you could see here, CNN will be equivalent to what? E. Okay, so here CNM, these are the CNM, the rotation through 180-degree, rotation through 240-degree. So like that, it is giving a similar configuration, but not the exact configuration. But here it is giving, CNN is giving the original configuration. So when we sum up in BF3 molecule, there are 2 proper axes of symmetries. Actually, they are 2 C3s and 3 C2s and one more identity element. We shall be discussing with few more examples in coming presentation.